Click on the subscribe button and press on the bell icon to watch my all new videos.
Good morning, hello my dear. So I don't know if this is a good morning or good evening for you, but for me this is a good morning. So today in this video tutorial I'm going to share with you gate, sprue and few gate problems, gate numerical problems, not theoretical. Those already asked in gate previous year papers. Okay, basically this tutorial I am creating because to help you to understand its basic concept of gate and sprue design, and of course that's so of course you can solve numerical problems, because my focus would be about 80% on numerical problems. That's why you will not face problem to solve numerical problems, right? So basically, as you know, what is gate? This one is not working. Okay, so what is basically gate? Okay, so basically gate, what is gate? I should share with you first. Suppose that we have a mold. I mean, we have to cast this part, right? We have to do casting of this object, so we'll create mold and all that, but we have to pour molten metal. That could be anything, maybe ferrous metal, non-ferrous metal, that is depend on us what type of casting we are doing. So for pouring this molten metal into this cavity, we required something that is known as sprue, basin, as well as gate. But basically we studied about sprue and gate in this, right? So and of course runner, we have to design also runner. So but most important for gate point of view, most important is gate. For gate point of view, I mean for gate examination point of view, most important is design of gate. And of course their types and what types of gates are there, I'm going to share with you in this video. So stay tuned and keep watching what I'm sharing with you. So first of all, let's go for the most important topic, that is sprue. Basically we start this thing with from sprue, right? So for understanding sprue and all that, I will go for a diagram. That is, I must say that elements of gating design. I'm going to share with you all elements of gate design. So let's go for that that diagram. So suppose that we have this one and this and this. So will this one, then we have to go with runner, then skip bob. I will share with you what are these things, that's why it will not face problem, right? We have to part this one, and then suppose that this one is our main cavity, okay, and this supporting elements is here, and we have to close this one, right? I hope you understand cope and deck and casting, all those things, but I'm not going to share with you cope, drags and cheek and all that. Yeah, so I'm going to share with you all important elements we used in case of this. Okay, so I hope I've done this now. So we have drawn this. Here I'm going to share with you all important elements. So first is this one is known as pouring basin, that's why you have idea. And this one is known as strainer, and basically strainer is made up of ceramic material, so don't get confused with this. And this is known as sprue, and this one is known as gate. And about these two topics, I have seen there number of times they have asked question, right? And this is known as splash core. This is known as runner, and this one is known as skip bob. Yeah, and last one is cavity, and this one is a riser. So basically this is the element. So we have pour molten metal here, then it will go here, from here to gate, and then riser, it will go out. So this is why riser is providing, because of shrinkage allowance and all that. Okay, so this is all about theoretical part. I must share with you, that's why I am sharing. And now I will go for the most important part, that is gate. But before going to share with you design of gate, let me share with you what type of basically we are using a sprue, and what are main important things we need to remember. Suppose that this is height of sprue. Okay, now this is 2 and this is 3, entering and the exit point. Now here one important formula, not one exactly, two important formulas we need to remember. If you are saying this is the height of base, you can say. So here 2 entering and exit is 3, so we can say at 2v2 is equal to a3v3. Okay, this is the one thing. Now if we'll say its ratio a2 by a3 is equal to a2 is equal to 2g ht, that means it's total height I'm talking about, ht, and a3 is 2g h, you can say b1, it's b1. Okay, so this is how you can relate things with, but because why it is happening, because v3 by v2, it's v3 and it's v2. So this is the formula we need to remember. But most important formula is we have to remember that velocity is equal to 2gh. This is most important. From these two will be, these two we can easily make if we know velocity is equal to 2 root under gh. Why it is happening, let me share with you how is it happening. Okay, we can, velocity, the unit of velocity is meter per second in SI, right? Just I am making you understand what is it. G root under, keep it root under, g acceleration due to gravity, its unit is meter square per second, right? So, and yeah, no, sorry, meter per second is square acceleration, and then h height meter, so root under meter square per second is square, what will happen, meter per second. What exactly, it's velocity. Yeah, I know that the unit of speed is also meter per second, but here we are talking about velocity only. So this is all about the simple concept of gate, not gate exactly, the simple elements, all that. Now we'll go for the gate and types of gate. I have shared with you what is gate. Basically it is going molten metal is passing through this gate to the cavity. Now we'll go for types of gate. What are types of gate, basically we need to know. We'll go for that. Okay, I need I need one other paper, I think so I should get here, right? Just a second. Yeah, what exactly I'm doing. Yeah, I got paper, some paper I have to get to share with you. Yeah, I got this paper. Now we'll go for types of gate. What are types of gate? Basically, if you have gone through little bit through any book, then you will see there are many types of gate. So basically there are 4 types of gate. Top gate, what are these, I will share with you. Bottom gate, parting line gate, and stab gate. These are 4 gates, types of gates if we're talking about top gate, bottom gate, parting line gate, and stab gate. If you now I'm going to share with you what are about this gate and what you need to remember if you wanted to have basic concept. And for getting numerical point of view, this top gate, from this top gate I have seen most of the time they have as question, most of the time they have as question from this top gate only. But bottom gate is also important because it is having few formulas too, just like top gate. And parting line and stab gate, probably they will ask you application of it. Yeah, they will ask you only application, nothing else, from parting line gate and stab gate. So don't get confused in that. Yeah, in case of top gate, what exactly we do, we provide the gate at the bottom of the sprue, right? So suppose that we have a sprue here, and this is a sprue, will provide gate here only before the cavity. This is known as top gate. If we are talking about bottom gate, then we'll provide at the bottom of the sprue, not at the sprue, bottom of the cavity. So suppose that this is a cavity, right? So we'll provide gate arrangement here, and of course we have to provide runner, then this one, and this like this. Yeah, so that's it, 1, and this one is 2, and I must say that this one is this is HT. So we consider this is gate. So this is known as bottom gate. We will provide the gate bottom of the cavity. Okay, so from these two, top gate and bottom gate, these two are most important for gate point of view. Okay, now we'll go for parting line gate. If you're talking about in industries and casting industries, most of the time they are using parting line gate. So don't be and why they are using, I'm just going to share with you, but they are using casting industries are using parting line gate to get the advantage of top gate and bottom gate. Okay, because through top gate maximum velocity with maximum velocity metal can be filled. That means it will take very less time to fill molten metal in the cavity. Now if we'll talk about bottom gate, then there will not be any maximum velocity. Of course, the molten metal will be having negligible velocity, and it will filled. That's because of pressure, because of pressure, you can say. So and of course there won't be any turbulence happen or erosion happen, and maybe splash. The cavity will not splash away. So if we'll talk about what type of application actually we have for top gate, we usually use top gate for ferrous material for using ferrous, and bottom gate we use only non-ferrous. That means in which material we don't have iron atom, or iron atom, you can say that, just like aluminium, right? So this is this one, you can say cast iron. We use this maximum velocity very, we can fill the molten metal into the cavity with maximum velocity. Okay, so this is top gate and bottom. Parting line gate we use to get advantage of these two types gate. What is it? Let me share with you. Suppose that this is a cavity, right? So in this cavity, what exactly we are doing? We just parting with. Okay, so what is happening here? You can say that this is like this, and if we'll say okay, then suppose that we are using this. Yeah. Or this one is not parting, this one is okay. So this one B, suppose that this is A, suppose that, and here this is a height. So what exactly we're doing from here to here? Suppose that this is a gate. Okay, so for A part it is acting like top gate. And for B part it is acting like bottom gate. So if we are using parting line gate, that means we are getting advantage of both gating system. Both gating system means top gating and bottom gating. Now if you are talking about step gate, now what is the application of step gating system? Basically, step gating system we used in case of very large size product. If we wanted to cast any very large size product, then we have gone through this step gate. Okay, so step gate means there are many gate would be there in single cavity. So for filling single cavity there would be many gate, just like one gate would be here, one here. So these are a step gating system. So now most important thing is that we use type of gating system. It is also depend on what we have to cast. Simple, right? What we have to cast, based on that we used these gating system. That's why we are having these types. Okay, because if we used only one, what's the use of having all gating system? So these all are having own importance. So top gate, we if you are talking about gate examination, then top gate is most important, and bottom gate is little bit important because it is having few formulas. So right now what I am going to do, I am going to go through few formula. I am going to share with you few formula. Those are most important. Once we'll go through those formula, then we'll go for problems. So what problems in gate examination already ask. Okay, so let's go for those concepts. For this again I need you need a paper, good paper, white paper. Yeah, so let's go for those formulas. So first of all we are going to talk about top gate. So in case of top gate, we required few formulas. Those are most important, or of course you need to know. So basically, you know what they have been asked in gate examination. I have seen most of the time they are asking that how much time will it take to fill the molten metal, fill the cavity by molten metal. Most of the time, that means they're asking about time, and for this I have a formula, that is T is equal to, for top gate, suppose that for top gate, AM VM AG 2H G. Here AG is area of gate, AM is area of mold or cavity, area of mold, and V is velocity. V is it's velocity, its area, and 2G. Yeah, it's, I'm sorry, it's not VM actually, it's HM. Okay, so this is height of mold. So actually what happened, if you multiple AM into HM, then what we got, volume. Area into height is known as volume. So that is the important, that's why I have written VM also there. So it's VM AG into 2GH. So this is for gate only, and this is for mold. I mean all these elements for mold only, and this is for gate only. So this is the formula we need to use for solving problem in top gate. Now let's go for bottom gate. Okay, again I should share here only bottom gate. So what formula we used in case of bottom gate, I should share with you, right? So let's go for that bottom gate formula. TF is equal to TF, suppose T field for bottom gate, B for bottom gate, 2 AM AG area of gate, 2G into, I should use different pen, into, this is multiple, this one is not working, yeah, this one is working, root under HT minus HM. HT means total height, this total height, okay, and HM means height of the mold. Now there is a case, if HT is equal to HM, means total height is equal to height of the mold, then we can say that to time required to fill the bottom gate system is equal to 2 into time required to fill the top gating system. Time required to fill what field? The molten metal to be filled in the cavity. Okay, so time required for bottom gate is twice if ST equal to HM. Okay, so that's why we can say that bottom gate system required more time as compared to top gate system. So this is the thing we need to remember. I mean, this is maybe they can ask in MCQ. Okay, so this is all about top gating system and bottom gating system and formulas too. Now what I am going to share with you, I am going to share with you numerical problems, those has been asked in gate. That's why you can do much better, right? So are you ready? I hope you are ready to learn those numerical problems. Then what are you waiting for? Let's go for it. Yeah, right now what we have a question that has been asked in 2012 in GATE 2012 examination, and this question has been asked for 2 marks. Remember that this question has been asked for 2 marks, and the question you can solve easily within 2 or 3 minutes. Just we have to read the question carefully and go through it. Okay, so what we have to do, we have to read the question first carefully. That is, a mold having dimension of 100 mm, 90 mm and 20 mm. So let's write volume of the mold VM is equal to 100 into 90 into 20, and of course its unit would be millimeter cube. Is filled with molten metal through a gate height H, and cross sectional area AZ is A. Okay, the mold fill time is T1. So this is the case, and it is taking time for T1. Now what is saying, if height is now quadrupled, means h is equal to 4h. That means suppose the total height is equal to 4h and the cross sectional area is half. That means AZ is equal to A by 2. This is for, suppose that this is case 1, and what writing I am here, it is for case 2. Okay, now this is it. Now let's go for the numerical problem. What is saying, the condition is this. Now what we have to find out, the corresponding filling time is T2. Okay, for this we are having filling time T2. Now we have to find out ratio T2 by T1. So what is T2 by T1? Okay, so we know that they did not say that what type of basically gating system they are using. So definitely if they are not not telling you what type of gating system you must use, then what you should do, you go for top gating system. Okay, so it is here T2 by T1 is equal to, okay, suppose that what is T1 basically, VM AZ into 2GH. This is what T1. Now V1 VM, suppose T2, for T2 what happened, VM same, volume is same, AZ2 into 2GH T2. Okay, so VM is same again, AG1 multiple 2GH T1. So VM get cancelled. What happened? This will go upside. So AG1 2GH T1 divided by AG2 2GH T2. Now what is AG2 basically? Half of AG1. So AG1 2GH T1, AG1 by 2 multiple 2G. What is HT1 basically? 4H. So 4HT1. So H, okay, this is the comparison, right? 4HT1. So what happening with here? This is cancelled. Now if you will write this, simplify this, what we'll get, 2GHT1, we got half here, so 4, if we'll take out this 4, then what we got, 2GHT1. So 2 get cancelled, this one cancelled, so answer is 1. So they should be what? C is the right answer, that is 1. So this is how you can solve numerical problems related to it. That's not all, my dear. I am going to share with you more numerical problems. That's why I will not face any kind of problem. I am going to share you 3 or 4 numerical problems in this topic only. That's why you can remember what I have shared with you, those formulas basically, because if you are preparing for GATE, then formulas play most important role than practice. Okay, so let's go for the next numerical problem. Right, my dear, so we got the next problem here. So in this problem, what we have given here, a mold has down sprue whose length is 20 centimeter. So just keep writing, length is equal to 20 centimeter, right? And cross sectional area at the base of the down sprue, that is cross section area, that is length means height, area is 1 centimeter square. The down sprue feeds a horizontal runner leading into mold cavity of volume, that is volume mold cavity 1000 centimeter cube. The time required to fill the mold cavity will be, we have to find out what time required. As I have shared with you in the beginning, pretty beginning of the video, what they will definitely ask you, time required. So most of the question they have asked in GATE, how much time will it require to fill the cavity by molten metal. This is the main thing, this is the main concept we need to grab to crack questions of GATE. So what is the formula for finding out time? Time required for filling the cavity is equal to volume of the mold, area of the gate, 2GH height, right? So volume is 1000, area is 1, 2G, just leave it, 20. Now here you are going to make mistake. What is that mistake? You will just put G is equal to 9.1 and you will not see the unit is meter per second square. So what you have to do with 9.81, you have to change its unit to meter, not meter, it's centimeter per second square. So you have to multiply with 100, then only you will get right answer. If you will not do this, believe me, probably one of answer will match and you will mark the wrong answer, and other than getting marks you have to give marks. So don't do this. Okay, so most important factor is that you have to remember unit also, what unit you are doing. So 2 into 20 into 9.81 into 100, so 1 by 2 is this much. So 1000 divided by answer is 5 point, the answer is 5.048 second. Okay, that the given unit is in the required time we have given, so this will come in, we are taking second, so it will come second. So 5.08, 5.0, okay, 5.045, so answer is here. 45 means if you get 5 here, 05, so answer is 2. So second option is the right answer. Probably if you are watching time, for solving single problem, you will not even take, it will not even take 2 minutes. But the thing is that you have to remember all formulas in your mind, and to remember all formulas in your mind, only remembering is not the key. The key is that you have to practice a lot numerical problems. Okay, so let's go for another numerical problems. Probably you are enjoying all tutorials, that's right, because I am making these videos with full of joy. That's why I am sure you are enjoying all these tutorials. Then what are you waiting for, my dear? Of course you are not waiting, I am waiting. So definitely I will share with you next question. Let's go for it. Alright, my dear, so we got another question here, and this question also asking gate. So what you need to solve this question, you need formula and of course calculator. Without calculator it will become little bit difficult for you to solve. Not for you, for all maybe. So the height of the down sprue is, height is 175 mm, and its cross section area at the base, AZ is equal to 200 mm square. The cross section area of the horizontal runner is also this. Okay, so assuming no losses, indicate the correct choice for the time second required to fill the mold cavity. So volume is again given 10 to the power 6 millimeter cube. Unit, you have to check unit, right? And we have to find T, time take to fill the cavity. Okay, T, again they are asking T. See, I did not get this question from my own. I got this question from previous year papers only. From internet I got all these. You will definitely find out all these questions from their official website too. So we have to find out T. So what is the formula for T? Vm Az root under 2gh. Here again you are going to make mistake, because g is equal to 10 meter per second square. So you have to convert it into mm. Then 10 to the power 4 millimeter per second square. Don't forget to convert this unit, because they already have given this unit. That means they want you to be confused in this, and you will make wrong answer. So you have to be careful. Now Vm is equal to 10 to the power 6, Az 200, it's 2g 10 to the power 4, h is 200. Now what you required? You required calculator. Don't worry, I'm just going to use it. So 2 into 10 to the power 4, sorry, it's 10 to the power 4 into 200. Okay, 1 divided by 2, what we got? 2000. Probably I'm doing right. So this one, so 10 to the power 6 divided by answer is 2.5. Is this 2. Am I doing anything wrong? I don't think so. Okay, so this one is not, h is 175, right? And this one is right. Now it's okay. So what we have to do, 2 multiple 10 to the power 4 into 175 is this, so divided by 2 is this, multiple 200 is this, and 10 to the power 6 divided by answer. So what is the answer here? You can see 2.67. okay, so time is seconds. Okay, so this will come 2.67 seconds. So D is the right answer for this question. Okay, so what you have to do, you have to just remember this formula, and you need to know how to implement things in this formula. Once you will come to know, things will become quite easier for you. Okay, another problem I'm going to share with you in this topic only. That's why you will have command, right? and in this question what we have to do, we have two questions given under this question, and the question is almost same. There is nothing, nothing rocket science like. Don't have given any rocket science. It's simple, right? So first of all, what we have to find out, we'll go through it, but first what we have to do, we have to implement the concept which I am just going to share with you. Okay, till now I have shared with you few numerical problems. Well, after solving few numerical problems in any topic, don't use, yeah, of course I can recommend you because it is benefiting me. Probably it will benefit you also. See if it will beneficial for you, then use it. Otherwise, use your own. I'm sharing you the concept I am using these days. That is, after solving, yeah, of course I have told many of my students to implement this. They have implemented, they got benefit. So what is the concept? What is the concept? The concept is here. Concept is this: you have to implement it, but you should implement after solving few problems in a topic. That means you know the formula. First, find out what you need to find out in the numerical problem. So in the first question, what we got? Volume flow rate. That means we have to find out volume. Volume flow rate means it is given, its unit millimeter cube per second. Its unit is here. What is millimeter cube per second? Its formula is 2g and into h. 2g into h, its velocity. For finding out velocity, 2g into h. Now what we have to do, we have to multiply this velocity with area to get this one. To get what? Volume flow rate. Because velocity meter per second and area meter square. What will get? Meter cube per second. If we'll do this in mm, then it will be millimeter cube per second. Getting my point? So first of all, what is our motto? To get velocity in millimeter cube, millimeter per second. So what is the formula for finding out velocity? 2gh. So what we have to do? 2g, what they have given, or what I have taken, take g? No. So therefore I will get default this 9.81 meter per second. I have to convert into millimeter. Okay, 10 to the power 3, this has been converted into millimeter because 1 meter equal to 1000 millimeter. We know that. Now h, what is the h here? That is height. How much height is here? How much height we have given? 250. Remember that. So 250. Now what we have to do, we have to multiple 9.81 multiple 10 to the power cube into 250 is equal to this much. 1 divided by 2 is equal to this much into area. Area is given. Is there anything? Yes, they have given diameter. So area would be pi by 4 into d square. Multiple pi divided by 4 into d square. That means 10 mm. 10 square is equal to, there is something wrong, right? Okay, double multiple. Yeah, you can say, yeah, this is the answer we got here, and probably I am making some mistake here also to write. So let's go for it. Calculation mistake. After calculation, here is the answer I got, that is 173, and you can see here 17. So if we'll just do it from here 3 to 5, 1.7 into 10 to the power 5, right? If we'll divide this 10 to the power 5, then what we got? 1.73. So right answer is here C. So this is how you can find out the volume flow rate. Okay, calculation, sometimes calculate mistake, or sometimes typing mistake. Okay, here is it. The mold filling time is in seconds. We have to find out time. So time is Vm, of course, Vm volume. Okay, the volume of the cavity by AZ, area of the gate, 2gh. So Vm, what would be Vm? That is important. Now we know it is what? It is a cubical form. So this will become LV into H is equal to 100 multiple 100 multiple 100. So 10 to the power 6, right? So this will become 10 to the power 6. AZ, area of gate, pi by 4, 10 to the power square. because 10 is diameter we have given in this question. So what we got here, multiple 2 into 9.81 10 to the power 3 250. So what we can do, basically we can get from this here also, because we have already done this, right? So what we have to do, we have to just divide 10 to the power 6 divide by this one, 1.7 into 10 to the power 5, right? Okay, so what we got, 5.88 5.88 we are getting answer here. So this is the answer. 5.48 is here because we are getting, because probably we did not take, after 1.7 we did not get values, that's why we are getting this one. If we have taken up to, I mean, 4 values up to values up to 4 decimals, then probably we could get the right answer, I mean the exact answer. This is the right answer. So this is how you can find out numerical problems, what they have been asked in GATE. So I hope this one of the this one of the lengthy tutorial, so it is really difficult to concentration. If you are watching till now, thanks for watching. You have great patience, and just go for it. You can do something. Bye bye, and thanks for watching. Bye. Hello my dear, this is Ujjwal Kumar Sen, and in this video tutorial you are going to learn about permeability. Basically, this is a topic of metal casting, and obviously I'm going to share with you all numerical problems, formula based numerical problems. Of course, without formula how could it possible you can solve numerical. So let's go for its permeability. Basically, what is it? If I will share with you the definition, then probably you will understand what is permeability. So definition is here, right? So what is the definition of permeability? Ability of the molding sand to allow the gases to escape, or you can say which allow the gases to escape, is known as permeability. I hope you understand the question. Understand what is basically it. It means if the ability of the molding sand to escape the gases, right, is known as permeability, and that therefore you can say, if you know the basic of casting, then this is really important, that it will allow the gases to escape, because if gas will be in the mold, then what will happen, the defects will be more in the casting, for which material we are casting, right? So that is also important. Now basically what you need to learn, so if you are preparing for university examination, then understanding the thing is important, definition is also important. But if you are preparing for competitive examination just like GATE, and this video is for GATE, because I'm just telling you basic thing, as well as the other part of this video tutorial I'm going to share with you a question, which question has been asked in GATE previous year paper, right? So the main key for GATE is numerical problems, right? So here is the formula for finding out permeability number. Pn is equal to Vh by Pat, and probably you don't know what is V, what is H, what is P, what is A, and what is T. If you will come to know, then you will understand what is this. So Pn means what? Let me make you understand what is Pn. One by one we will understand, right? Pn means permeability number. V means volume of the air passing through it, right? And H is height of the standard specimen, height of the standard specimen. And what remaining? A, area, and T, time. Remember, time we will take in minute, and all letters will be in centimeter. Okay, so in this problem what in they ask in gate, we are also maintaining this centimeter and minute. Okay, so don't get confused in this, and if you solve few problems then you will understand what you need to take and what you don't need to take, because this is important. Okay, so what is here? Okay, now permeability. So now let's go for that problem, but before going to solve that problem, let me share with you one thing, that is pressure always, what is yeah, that is P is pressure. This pressure always given, I have seen numerical problems, right, gram per centimeter square. And one thing is area can be find out by this formula, pi by 4 into d square, and this height is equal to h is equal to 2d. And the diameter, I mean sorry, s equal to d, basically yeah, d. And of course this d, what is this d? The diameter of the specimen, that is sand, right? So basically what we are taking here, that is important. So height, height, we are taking this as a diameter, right? So diameter, relation between diameter and height, what is that? So height is equal to, we are taking 2d of that specimen, and 2d, d means 2 inch, 1d is equal to 2 inch. So you can say that what the hell I'm talking about h is equal to it equivalent to d, and it's equivalent to 2 inch. 2 inch means 2 into 2.54, that means if I'll calculate 5.2.54 into 2, that is 5.08 centimeter, because 1 inch is equal to how much? 2.54. That's why we have written this. So we got h, the value of h, and we also got the value of here what is area, d. So this d, small d, is equal to capital D, let's say this. So you can use only one, that's why you will not confuse, right? So this is all about the theoretical part of permeability. Now we'll go for that numerical problem which has been asked in gate. So that's why you'll have some approach to solve numerical problem in this topic only. But the main formula is this, P and permeability number equal to VH by PAT. This is important. You need to remember this formula to solve numerical problems related to this problem, related to this topic, right? So here is the question we got here. And in this question what we have asked, the permeability of molding sand was determined by using a standard sample, and which is passing through 2000 cc of air. So what is V? Basically 2000 cc means cubic centimeter, that means centimeter to the power cube. Remember this. Okay, usually we come to know how much cc bike is, engine of the bike, cc in cc, because it's stand for volume, right? The gas pressure is given how much? 10 gram per centimeter square. Okay, if the time taken for the air to escape was, so time is equal to 1 minute. Now we have to find out Pn is equal to what? Well, I have already shared with you. If you are solving any gate numerical problem, and if you are not beginner, if you're beginner, then probably the concept I am just going to share with you will not work for you. Probably you will be in trouble if you will follow that concept. But if you know the concept of solving numerical problem in any topic, then my concept will help you a lot. So if you are not beginner, then what you should do, you should first of all, for solving any numerical problem, formula is required. If you know the formula, that means you are not beginner, you have something, right? So first of all, go to the end of the question, just like here, what you need to find out from that question. And here what we got, the permeability number we need to find out, that is Pn is equal to what we should know. So Pn is equal to what? Vh by Pat, right? So in order to get the value of Pn, we need to have values of all these things, and from where we can get these values? From this question only. Are you getting my point? So I'm going little bit reverse, okay? Yeah, that's why it will be helpful for you, and you will find out exactly what you require to know. So what we needed here, volume V, actually we have given, right? Now P is given 10, area is not given, time is given 1, area we have to find out, and V we have given, then we have to find out H. As I have already shared with you, H and D, H is equal to D is equal to 5.08. So here just it is right 5.08, and I think, yeah, I have already shared with you, yeah, I'm just seeing that that page. I have already shared with you, area is equal to what, 5 by 4 into d square, 5.08 square. So this is this is how you can got or information what you required exactly. You just don't need to read the question, then that is the old method. What method I am sharing with you, this is the recent one. If you follow this method, you can solve numerical problem just like that. Just find out what you need to find out from the numerical problem, then write the formula, then go for it. Okay, so this is the shortest method and the right approach to solve numerical problems. But to use or to implement this method, you need to know something about the topic. Without that, that's not possible to solve the problem. Okay, right now what we have, we got this equation, and you know what we require right now. Can you guess? Can you guess, my dear? Can you guess? Yeah, I think so. You can guess, but I don't know you can guess or not. But yes, we right now we require calculator. So here I got calculator, right? So 2000 multiple 5.08 divided 10 into 1. Don't need to write, but even then I'm writing. Okay, so it's pi. Okay, just a second. Pi by 4 d square 5.08 a square bracket close. So what we got here, 550.1275. So can you see the answer, which answer is right for this question? I hope you can see, right? So the right answer for this question is A. So basically, for solving this question, what we required, we need to have this formula first, and we need to have all things that we know in which unit the things will be. This should not be changed in second. If you will change, then you are not going to get answer. So that is not the way to solve the problem. So what we have understand in this problem, in this tutorial, we have understand what is permeability, what is its formula, and all things we have used in this formula in details. So this is all about permeability. I hope you understand, you grab something new from this video tutorial. Thanks for watching. See you soon in my next video. Bye bye. In this video tutorial, I'm going to share with you shrinkage in casting, right? So basically, what is shrinkage and casting? Basically, you know that this is the one of the part, what we do actually, we got molten metal and we pour that molten metal in the mold, and then we take it out after solidification. That is known as casting, right? And in case of shrinkage, what is shrinkage basically? That's because of casting process, it's there is a shrinkage. That means changes will be taking place in volume, or yeah, you can say that changes will be taking place in volume. So basically there are two types of shrinkage, first and second. First is liquid shrinkage. When liquidification is going on and there is the shrinkage is happening, that is known as liquid shrinkage. And another one is solidification shrinkage, and it's a shrinkage when there is a constant freezing temperature, and during phase transformation, you can say that. And if shrinkage take place in that time, it is known as solidification shrinkage. Okay, so this is all about shrinkage. Now actually basically why I am creating this video, to help you out to solve numerical problem or problem asking gate, right? So basically if you are preparing for university examination, then one of the types of allowance, you can say that in shrinkage, what basically we studied, it's whenever we study about pattern. Okay, so you can study pattern, and then gate, a riser, a runner, and then sprue, all things from here only, because I am going to share with you only a conceptual as well formula based things in this series of tutorials, right? So in patterns, we definitely give one thing we consider. I must say that we consider allowance, and shrinkage is one of the allowance. And in this allowance, we got from this topic, pretty topic only, we got several questions in gate. So basically I am creating this video to help you out, right? So probably you are looking for, just like in my almost all videos, I usually share some theoretical concept as well as some some numerical concept. Those numericals already asked in GATE previous year papers. So basically in case of this topic we got two questions, those already asked in GATE. Okay, so probably you are looking for those topics, right? So let's go for it. Well, I could share with you more here in case of string case, but I don't want to share with you because you can easily get all those things from any book. So what's the use of sharing with you? And one more thing, what is the other name of string case? That is contraction. Other name of string case is contraction. Okay, so don't get confused if in examination they will have, maybe they will give there is contraction is taking place because of solidification or because of liquid string cases, liquid contraction is going on there. So you can get such type of thing, but yes, you should remember this because it's in English, right? So let's go for those questions I have already prepared for you. I have already written. That's why it will not take that much time to share with you. So these are two questions already asked in GATE. Okay, so unfortunately I did not write the options, but don't worry. I will share with you each and everything. Actually basically this question has been asked in GATE to confuse you, and I am sure when they have asked 80% student did solve the question, those knew about this string case concept, and among the 80%, 90% students did this question wrong. You know why? Because in case of gray cast iron, it will not shrink case. When there would be liquefaction will taking place, I mean it will allow to, you can say that gray cast iron size is this, is produced by sand casting. The pattern making allowance is 1% ratio of volume to the pattern. That means volume of the casting to the pattern. That means what they are talking about, suppose that I am making a pattern, cast iron size is this. Okay, so it's in it's in 3D, so I could share with you in 3D also. Yeah, suppose that this is 10 and this is 100 and this is 200. Okay, let me use another pen. Yeah, another color pen would be much better. So these are things they have given. So what they said, to make this, I mean to casting of this, for casting of this size of iron size, gray cast iron size, what pattern we should have to make, right? So basically what happened in case of gray cast iron, it will not shrink case. That means we have to make a pattern of less size. Are you getting my point? We have to make a pattern of less size because gray cast iron will not shrink case, it will expand. This is one of the property of this is one of the property of gray cast iron, it will expand. That's why that's why it we have to, this is a pattern size. Suppose that this is a pattern size and this is the casting size. That means pattern size will be less. So if you're talking about volume of, if you are doing with any other material, I mean if you are casting of if you are doing casting of any other material, then definitely it will be opposite. That means pattern will be bigger than the casting, actual volume of the casting. But here pattern is lesser than actual volume of the casting. Are you getting my point? So this is all about it. Now if you're talking about gray cast iron is here, right? Now what we have to do now, we have to put concentration on one thing, that is we have to find out ratio volume of pattern by volume of casting. We have to find out this ratio. Okay, so for finding out this ratio right away, what we have to do, we have to know the volume of pattern. They have already said the volume of the cast iron, that is 200 into 100 into 10. Now we have to find out pattern, that definitely it will be less than volume of the cast iron, gray cast iron. Definitely you should remember this, gray cast iron. Then 1% allowance is there. Then what will happen, there would be 1% decrease in every term. That means everything, L, suppose that this is L, this is B, this is H. Let's suppose this, the length, breadth and height, definitely there would be decrease in the pattern by 1% in every part of the body, length, breadth and height. So 1% means 1 in 100. So 200, 200 in 200, how much we have to write? 200 minus 2, 198. 198. Then in 100, of course, 99. In 10, here you are going to make mistake. You will just write 9. Don't write that, because it's 1%. 1% means 1 in 100. So what will happen here? 0.1 only. So it's 9.9. Don't make mistake here. I know there are many students make mistake here, and they did it right. That's why I'm sharing you this mistake. So there are two mistakes you can make here. One is here, another one is here. So you have to focus on these two places while solving numerical problem, right? So what we got the answer, let me share with you. I got calculator. So 198, 99, it's 9.9 divided 200 multiple 100 into 10. So what we got, it's 198 multiple 99 into 9.9 divided 200 multiple 10, 100 multiple 10. So it's 0.9702, its ratio. So answer is 0.97. It's the right answer because I have already done this question. So there is no need to be panic. I mean, don't require any option, all that. Now another question we got. This is this is also related to it. A cubic casting of 50 mm side. It's cubic casting 50 mm side. So first of all, let me draw, and I am sharing with you. Don't draw these diagrams in the examination, because I am sharing with you this drawing because probably you are beginner. If I will not draw all these, then probably what will happen, you will not understand what I wanted to make you understand right away. So suppose that we have a cube, and one side of definitely its side will be 50 mm. So every side would be 50 mm, right? 50 mm. So what this question, the statement state that site undergoes volumetric solidification, shrinkage and volumetric solid contraction on 4% and 6% respectively. Okay, there's shrinkage and contraction, both are same. I have already shared with you, right? On no riser is used. Assume uniform cooling in all direction the site of the cube after solidification and contraction. That's right. So there these are both are same, shrinkage and contraction. I have already shared with you, right? So this is 6% and this is 4%. Now think about it. The volume, there is a change, there is a shrinkage in volumetric shrinkage. Now you can see, you can get here only. Volume of this cube would be 50 to the power cube, right? So let me write properly, 50 to the power cube. So in this cube there is contraction of 4%, right? So after contraction, what will be remaining, that is, this is the contraction, right? So we have to find out size of this side after contraction. I mean shrinkage, yeah, just 4% shrinkage is there. Okay, shrinkage. So what we got values here, right? Just 50 to the power cube into 4 divided by 100, divided by 10. We can let me write, yeah. So this is it, and let me just do it again. Multiple 4 divided by 100. So I have to write this is volume, right? Volume, contraction, volume we got. Now we have to find out how much contraction is taking place there in size. I mean inside, as maybe length or breadth, maybe height. So 1 divided by 3 is equal to how much contraction is there. There's something wrong going on, I think so. 50 to the power cube into 4 divided by 100. 5001 divided by 3. So it's 17.04. What do you think? Is there anything wrong? Probably 4% is there. What we got here, basically 4% shrinkage there. So if 100% is there and there is 4% shrinkage taking place, that means remaining what? Point this. So because 4 by 100 is equal to 0.04. So remaining what? 0.96. So we can find out its its side. Just think about it. We are having volume meter cube 0.96. After cube root, we are going to get side. So what we got here, 50 to the power cube into 0.96. Okay, it's 49.32 mm side would be remaining after 4%. Now let's go for 6%. 6% means 0.06, so there will be remaining 0.94. So definitely what will happen, we have to find out cube root. 50 to the power cube 0.94. So 50 to the power cube into 0.94, this much. 1 divided by 3 because this cube root, so 48.97. So these are two answers we got here, 49.32 and 48.97. Yeah, so this is all about these questions and the same case also. I hope you enjoy the tutorial. Thanks for watching. See you soon in my next video. And of course, why I'm making this video is a little bit numerical oriented, because I want you to perform well in the competition examination just like it. Thanks for watching. Thanks a lot. Bye bye. Alright my dear, so in this video tutorial I am going to share with you gating ratio. Well, let me share with you, this is one of the most simple, as well as this from this topic in gate they have asked many type questions many times, and most of the time what we do, we got confused because we don't know exactly the step to remember the gating ratio. That's why we try to remember, I try to mug up, or probably you're thinking why I'm talking all these, why I'm not telling you exactly what I'm going to share with you. Don't worry, I'm just going to share with you the gating ratio. So basically what is this? It is the ratio, I must say, among area of sprue, AS, area of sprue first, second area of runner, AR, and third area of gate in AG. So there are three things basically, and among these three things we are having ratio, and we have we have know its ratio like this, AS. Yeah, so this is the gating ratio, right? So basically AS ratio, AR ratio, AG. So this is the gating ratio, and this is a ratio among AS, AR and AG, right? Now most important thing, how you can remember this ratio, so this is, I'm just going to share with you how you can remember about it, right? So ABCD alphabet, how we can remember this ABCD alphabet from starting from ABCD. Now see, in alphabet what will get first, what will get among these three? G, definitely. Then we'll get R, then we'll get S, 2 and 3. Then what will happen? What is the meaning of this? It's meaning that G, you need to remember what will come first, that will come last in this ratio. First is G, that means in this ratio last will be gate, second last, that's in middle, R, and the last one is S. So last one will come first, middle leave it, and the first one will come in the last, according to alphabet. So in this way you can remember its ratio, how you can do ratio, right? And basically if you did experiment on this on casting, that definitely you can remember without using any tips, because you know the process basically, right? So this is all about gating ratio. Now there are two things and two types of gating ratio basically we studied. One is non-pressurized, and another one is pressurized. One is pressurized and another one is non-pressurized, right? So what is non-pressurized and what is pressurized, that is important. So it is depend on the gating ratio too. If you are talking about examples, if you want to know examples of non-pressurized gating system, then it's like this: 1:2:3, 1:2 maybe 2.5, 0.5:1:2, 2.5, you can say. These are all examples of non-pressurized gating system. And if you are talking about examples of pressurized gating system, then it is having different, just like a 3:2:1, 2.5 is to 1 is to 1.5. It's a non-pressurized gating system. Now next is pressurized gating system. Now next is 2:2:1. Just like, there are many examples you can give for pressurized gating system. So this is how you can, you can classify types of gating system. You can understand types of gating system ratio. One is pressurized, another one is non-pressurized, and also you can come to know how to do how to arrange gating ratio right way. So this is the right way to do gating ratio. Right now, what I am going to share with you, that is also important. I am going to share with you two questions. Those questions has been asked in GATE previous year, and I am sure this question will be quite will be quite helpful for you too, right? So what are you waiting for? Just let's go for it. Those questions will be here only, right? So here are those questions. So we got these two questions here. One is the pressure at the gate at in the gate. Okay, it's the that should not be there. You can say at the pressure at in gate will be maximum will the gating system. So it is talking about pressurized gating system. Pressurized gating system. So as I have shared with you here, the last AZ, then AR, then AS, area of sprue, area of runner, area of gate. So if they are talking about pressurized gating system, that means gate 1 must be minimum at least. So among all, which one is having gate minimum? This one cancel, this one cancel, this one cancel, remaining one is this. So 1:2:1 is the right answer. That is, this is a pressurized gating system. Okay, so probably you will get confused of 1:2:1. So we have to see for pressurized which one is minimum, because in the examples I have shown you, in the examples you can see that every example in case of pressurized gating system, the gating ratio is minimum. The gating, that this one is in gate, so area of the gate is minimum, and it's a ratio of all areas, right? Area of sprue, area of runner, and area of gate. That's why it is known as gating ratio. All right, so the first question has been solved, and I hope you understand the concept to solve problem. And I am sure if you'll get question in GATE upcoming examination, then definitely you can solve the problem without any hesitation, and you can mark the right answer, right? So this is the first question. Now let's move to the next question. What we have in this question: in a gating system, the ratio of 1:2:4 represent. So in a gating system, the ratio of 1:2:4 represents. So gating system, in any gating system, what type of ratio do we represent basically? So what we got here, we got four options here, A, B, C, D, right? So in this option, what you can do, just think about it. The ratio is 1:2:4 represents. In a gating system, what it should be like this. Okay, so the answer would be what? You can say that. Can you guess it? So basically, if you're talking about non-pressurized gating system, then it's a perfect. This is the perfect one. So basically, in case of non-pressurized gating system, it could be pressurized one, could be non-pressurized one. But if you're talking about what type of gating system they're asking, this is non-pressurized, right? Because the area of the last one is always area of gate. Area of gate is maximum. That means this is non-pressurized gating system. So we have to, that is not the question they have asked in this question. They have asked what time. They are just trying to confuse you by giving you this. So basically, what is the ratio of gating? I have already shared with you, and from this page only you can solve all problems. Although I have written only two problems. So what is the ratio? Basically, area of sprue, area of runner, and then area of gate. Okay, I have told you also how to remember this ratio. So the same ratio we have to get from those options. So we have given options here. So first of all, we have to see from last side, right? So casting area, last one, this one is wrong, and runner area, this one is wrong, casting area wrong. So the option is B. And now let's compare with this option B, because we are not sitting in the examination, we are here to discuss things much better way. That's why you can understand things much better way. So what we got here, just let me use another pen. Red one is quite good, isn't it? So sprue, area of sprue, and runner, area of runner, and then area of gate. So is this ratio I have already shared with you? As you can see here, yes, the same ratio I have already shared with you, what we got after comparing the written form, right? So that means we have what answer we have chosen here, that is right. So in case of getting ratio, what is important, basically what is important, what you have to remember, that is also important. So first of all, you need to remember this ratio first. Second, we need to remember 2 points: when the getting ratio will be pressurized, when the getting ratio will be non-pressurized. And how to identify, I have shared with you, that is, you have to see that in case of pressurized, area of the gate would be minimum. So in this way, you can, one thing you need to remember, in this way you can solve any problem related to it. It's a simple topic, I know, and I hope you have clear all things in this topic through this video tutorial. Thanks for watching, and see you soon in my next video. Bye bye. Hello my dear, this is Ujjwal Kumar Sen, and in this video tutorial I am going to share with you solidification time. Yeah, this is a topic of casting. You know that probably, that's why you have landed this page. And in this topic I am going to share with you a principle, principle, principle or rule, right? So this is about it. I mean, this is a principle, and this rule is a rule which is known as CHBU. This is a little bit difficult spelling because it's a name, Korinov's principle. This principle is known as Korinov's principle. Okay, I hope you got it right now. Okay, so according to this principle, what this principle basically states, I have to share with you. This principle states that solidification time is directly proportional to the shape of the casting volume divided by surface area its whole square. And we can also write this TS is equal to K volume by surface area whole square. This K is known as solidification factor. This K is known as solidification factor. One of the most important thing in this video I am going to share with you, that is, what is the unit of K? You need to know. So how you can able to find out its unit, just I am going to share with you. Probably you will forget in exam. So this is solidification time, right? That means in second, if you're talking about SI unit, second. K, leave it. Volume, meter cube. Surface area, meter square. This sorry, okay. So this one is one cancel, m would be remaining, so m square. Then K is equal to second per meter square. So what is the unit of K? Second per meter square. Remember this. Unit of K is second per meter square. I hope you got its unit, right? So now let's go for few shapes. Okay, shape, like what type of shape we wanted to cast. Based on that, we can find out solidification time. That means solidification time is also depend on the casting, I mean the shape of the cast. Okay, the shape which for which shape we wanted to cast. Okay, so let's go for it. First, let's go for cube. I hope you can see. Yeah, for cube volume by surface area, it's cube, AQ surface area 6A square. So it's A by 6, right? Now second, let's go for cube. What is cube? Let me share with you first. Probably you forgot. Okay, I know you know. This is a cube, right? Whose length, breadth, and height, all three are same. That is known as cube. Now let's go for a sphere. Okay, suppose that this is sphere and this is diameter and its half part is known as radius. So volume by surface area. So the volume of the sphere is 4 by 3 pi r cube. Its surface area is 4 pi r square. And after calculation, what we get, pi get cancel, 4 get cancel, r. So r by 3, that means d by 6. This is for sphere. I'm just trying to share with you relation between volume by surface area of different shapes. That's why when will you get questions in the examination, it will become quite easier for you to solve the question right way. To solve the question also in very less time. That's why I'm doing all this. Now let's go for cylinder. Okay, cylinder, this one is for cylinder, right? So in this cylinder, let's say its diameter is d and height of the cylinder is h. So volume by surface area, volume cylinder, what is the volume of cylinder? Pi by 4 into d square into h. Okay, now surface area 2 pi by 4 into d square plus pi into d into h. This is the formula. Now most important thing, if we are considering a cylinder whose height is equal to diameter, then the case, what would be the case for this? If height is equal to diameter, then what would be the value of volume by surface area ratio? That is interesting, right? So let's just put the value and get the answer. So pi by 4 d square into d divided by 2 into pi by 4 into d square, pi d square, because h is equal to d. So what we got here, pi by 4 into d cube, it's 2d common 2 pi d square plus 2 pi d square. What we got here, therefore pi by 4 into d to the power cube 2 by 3 pi d square. Pi get cancelled, 2 by 2, so the remaining would be d cube by 6. Now most important thing we can notice here, it's not d cube basically, d cube by 6d square, so d by 6 would be remaining. So now let me write first in figure. D by 6 we are getting for cylinder if h is equal to d and its volume by surface area ratio is d by 6. Now look at the volume by surface area ratio for sphere. That means volume by surface area ratio for sphere and cylinder both it's same. For both it's same. So don't need to be confused in it because it's really simple. So this concept, actually based on this concept, in GATE examination they have asked you a question for 2 marks. Just after sharing with you another shape, I am going to share with you that question, how to solve. Even I will share with you how to solve that question. That's why you can understand, you have understood hopefully Cronin's principle, and you can also understand how to solve problem based on this principle. This is the main motto of creating this video. I hope you are getting me right now. Okay, so let's go for that that last shape. So I am talking about in the last shape, that is, let's say it's a slab. Okay, what about slab? Length is there, breadth is there, and height is there. So for slab, volume by surface area ratio LBH to LBBH plus HL. This would be the ratio volume by surface area. So this is all about the concept of solidification time and based on Cronin's principle. Okay, so now let's go for that problem which has been asked in GATE. I hope you are interested to learn that problem, right? So let's go for that problem and solve it. That would be quite easier and quite helpful for you. Now here is the problem. So what we have given in this problem, let me just share with you. In sand casting process, sphere and cylinder of equal volumes. So both the volumes are equal. Now what I have shared with you right now only, volume. If volumes are equal, so what is the formula for volume for the sphere? 4 by 3 pi r cube. What is the formula for volume for cylinder? Pi by 4 d square h. Okay, so we should write here volume of sphere 4 by 3 pi r cube, volume of cylinder pi by 4 d square into h. These two formulas we require to solve the problem. That's why I have shared with you all formulas. Now next, separately cast from the sand molten metal under identical condition. The height and diameter of the cylinder are equal. So here the condition h is equal to d in case of cylinder only. Therefore this equation become pi by 4 dq. Okay. Now what we have to find out the ratio of the solidification time and sphere to that of the cylinder. That means we have to find out ts by tc. Solidification time of the sphere to the cylinder, then we have to find out ts by tc. Okay. Now let's go for that. How to find out ts by tc? That is also important. Once you will come to know how to find out, then things become easier for you, right? So we have to first know the relation between sphere diameter as well as cylinder diameter. Once we'll come to know relation between sphere diameter and cylindrical diameter, then things become easier for us. Okay, then we can find out area and all that. That's right. Let's go for it now. So what we got basically here is that, so what we can write here, by 4 pi d by 2 whole to the power cube, right? So pi by 3 4 by 3 pi dq by 8. So this will become pi dq by 6, pi dq by 6. So as in this question what state equal volumes, that means pi by 4 dq is equal to pi by 6 dq. Now this d is for sphere, this d is for cylinder, that we have to denote. So we can write pi by 6 dsq is equal to pi by 4 dc cube. 5 pi get cancelled, 2 2 is the 4, 2 3 is the this one. So ds is equal to dsq is equal to 3 by 2 dc cube, because I'm sending this 3 to that side. So because of the rule of the cross multiplication, we can write that. Now ds is equal to 3 by 2 dc cube, and we can write 3 by 2 dc cube. This is cube root, and because dc is cube, that means it will dc. So what we got here till now, ds is equal to, we need calculator, right? We need calculator. 3 by 2, this one we have to find out cube root. So 1.145, okay, this is, or 1.1447, because we have to take up to 4 decimals values. That's why we can get very good right answer, right? So ds equal to 1.1447 dc. We got the relation between diameter of the sphere and diameter of the cylinder. Now what we have to do, we have to find out, we have to do what? ts by tc. Now I have already shared with you the relation. What will happen in case of cylinder? If h is equal to d, then volume by surface area ratio is equal to d by 6. So in case of d by 6, dc by 6. Okay. Now in case of a sphere, d by 6, so ds by 6. Got it? How then? Now you can understand how the what I have shared with you in the earlier is useful right now. Probably you have landed in this on this page right now only, then probably we are seeing what is going on here. But if you watch the video from beginning, then you can understand what right now I'm talking about. It's really important. It's really in-depth concept what I am sharing with you right now. Now what we got here, ds by 6, 6 by dc, 6 get cancelled. What we have right now, ds by dc. Now what is the value of ds? Okay, what is the value of ds? You can say okay. Now what we have to just write square, because we know that ts directly proportional to volume by surface area, its whole square. So okay, so what we got here, ds by dc. Now ds, what is the value of ds? What is the value of ds? Ds is equal to 1.1447 by dc and dc. So dc gets cancelled. From where we write this. So 1.147 square. What is the answer? 1.1447 whole square is equal to how much we are getting here? 1.3103. Okay, it's ratio, that's why it is unitless. So answer is 1.31. A is the right answer. So this is how you can solve problem related to solvation time based on Karinoff principle. I hope you got some inside information about this topic and you have enjoyed the video. Thanks for watching. See you soon in my next video. Bye bye. Hello my dear, this is Ujjwal Kumar Sen, and in this video tutorial we are going to learn about chalk area. Well, probably you know what is chalk area. This is one of the area which we generally consider for gate design. Well, we are talking about metal casting. So in chalk area. So what is basically chalk area? Let me share with you first definition. That's why you can have some basic concept of it. Definition: it is the minimum cross section area in all the gating elements. I hope you have watched that video, which was length I think around more than 30 minutes, and in that video I have shared with you a lot of numerical problems as well as about sprue and gate design. So in that video I have shared with you types of gating and gating elements too. So I don't want to repeat those things in this video too. So definitely from this definition we can understand what is chalk area. Right now, why I am sharing this video, you can easily read this definition. I am sharing with this video because I wanted to share with you a thing that is numerical equation. Numerical formula. Chalk area is equal to basically m density time for filling coefficient of discharge 2g h t, total height, you can say that. So let me share with you what is m. M is mass of the casting. Density, this is density, so density of the material. Density of the material. TF, what is TF? Filling time. What is filling time? Basically molten metal filling time in the cavity. And then CD, that is coefficient of discharge. And then HT, what is HT? Height of the liquid above the molten metal. Basically this is molten metal above the gate. So this is this is all about all elements we have used in this formula. I hope you got the formula right now and you don't have any confusion related things in this formula. So probably what happened, maybe in the competition examination they will ask you to find out chalk area. And what is chalk area I have already shared with you. Right now what I am going to share with you, which is also important, that is where exactly we have this chalk area in case of pressurized gating system and non-pressurized gating system. Once you will come to know where we have this in case of pressurized and non-pressurized gating system, then the assumption or the thing, the what I am talking about basically, where exactly that chalk area would be, you can visualize about it. Once you will come to know and you can visualize about it, it becomes quite easier to understand. One more thing, you need to remember this formula, and probably how examiner can relate this with the formula. Let me share with you. Basically what happened, density equal to mass by volume. Mass by volume. So volume would go up, and if mass get cancelled, then you know what will happen. Volume by TF CD root under 2GHT. we can write, that thing we can write, right? But here we got this formula, and we they can relate this formula with the here 2GHT. What is the meaning of this? This is what flow of molten metal, that means molten metal velocity in that gate design. So examiner can relate this formula with the design of gate. However, I haven't seen question till now in gate that they have relate this, and probably they can relate in upcoming examination, who knows. Alright, so I hope you got it. Now I am going to share with you two things what I have just shared with you, that is where we have this chalk area in pressurized gating system and as well as in non-pressurized gating system, right? So let's go for it. Now can you guess? Okay, let me share with you another way is there to tell which one is pressurized gating system and which one is non-pressurized gating system. I'm just going to share with you that too. That is, that is okay. I'm going to share with you. But here, this is a non-pressurized gating system. Here it is having minimum area, that is known as chalk area, and in this case here we have chalk area. This is known as pressurized gating system. So now what from these two figures we can figure out where we have chalk area in case of pressurized gating system and where we have chalk area in case of non-pressurized gating system. That's right. Now what I was talking about just before, that how we can tell about the system, I mean the casting is going on anywhere, right? How we can tell that this is a pressurized gating system or non-pressurized gating system? Can you say this? Actually, I have already shared with you a video about it, that is known as gating ratio. I'm just going to tell you in brief about it. Gating ratio. Through gating ratio you can tell that this is a pressurized gating system or non-pressurized gating system. How? Actually, what is basically gating ratio? There are three things we usually take: area of sprue, area of runner, area of gate. How we can remember it? Watch that video, you will come to know. I have shared one of the simple tip to remember it. Or maybe you are thinking, why should you go for that video? You wanted to know from this video only, right? Yeah, I'm telling you how to remember this ratio. I mean, how to remember this, from what we have to start from first, what next, and what next. Just think about it. In our English alphabet, what we get first among these three letters, G, R and S? G, right? So first letter is last, second is in middle, and third last letter is the first. This is in reverse direction, right? I'm telling you again. In English alphabet, among G, R and S, what we will get first? G. So this is a last here, third. Just reverse this. R second and S third. Just reverse this. G third, R second and S first. So S, AS, R, AR and AG. These are all ratio, and this ratio is known as gating ratio. I hope you are getting me what I am trying to make you understand in this concept. Okay, now go for it. The pressurized gating system and non-pressurized gating system, because I have shared with you through this gating ratio you can tell the casting system is pressurized or non-pressurized, right? If anyhow you can tell this, then things become quite easier for you. Then let's go for it. In case of pressurized gating system, the area of the gate is always more, is always more in case of pressurized gating system. I mean, sorry, non-pressurized gating system, the area of the gate is always more. For example, 1:2:3 is an example of non-pressurized gating system, right? This is an example of non-pressurized gating system. Now if you are talking about pressurized gating system, then what should be the example? That is 3:2:1. that means the area of gating ratio, if area of the gating ratio is minimum, this is known as pressurized gating system. Now think about it here. Chalk area, this is the gate, this is the gate, chalk area is here, that's why it is known as, I mean, whenever chalk area is near to the casting, then that system is known as pressurized gating system, you can say that also, right? But now one example I would like to share with you, that is 1:2:1. Is this pressurized gating system or non-pressurized gating system? Can you say this? Which one is this? Pressurized or non-pressurized? I have shared with you, if we got minimum value, minimum than this, that's why it is known as pressurized gating system. Okay, now what I was thinking to share with you, that is, in case of non-pressurized gating system, what type of material we usually cast? In case of pressurized gating system, what type of material we usually cast? Probably you wanted to know, right? In case of non-pressurized material, we cast non-ferrous material. That means which material is not having any carbon atom. That, for example, aluminium is a non-ferrous, and that's why we used for this casting, for casting this material, we used non-pressurized gating system. But in case of pressurized gating system, we used ferrous material. Ferrous, you can say, ferrous metal which is having which is having iron atom. Just like, for example, you can say steel is there, that is a ferrous material. So this is how you can understand about pressurized gating system and non-pressurized gating system. I hope you understand a lot and you got very good concept from this chalk area video. Well, thanks for watching. See you soon in my next video. Bye bye. Hello my dear, this is Uchal Kumar Sen, and in this video tutorial I'm going to share with you about upward balancing force, right? So what is this? Basically this is a force, right? And if you are newbie, totally newbie, and you don't know about this topic and directly you have landed on this page, then let me share with you, this is a topic of casting. So basically what happened, we do casting, right? We used core material, and here what we have to find out, the upward balancing force in the cavity. Okay, probably because of that molten metal, probably because of that core material, and all things together responsible for this. So basically this is denoted by, suppose that we are denoting this by F, then we know that F is equal to V into G. Don't worry, I will shed the what about this, rho m minus rho c. What is F? Upward balancing force. What is V? Volume of the core. What is rho m? Density of the molten liquid metal. And what is rho c? Density of the core material. And G, 9.81 meter per second square. Yeah, focus on unit, because unit play most important role to solve the question right away. Okay, so this is all about all things in case of the formula for finding out upward balancing force is here. Now what we can do, basically in gate they have as question related to this formula, that's why I am sharing with you that the formula is this. Now what next, how it would be quite helpful for you, that is practice. So I am going to share with you a numerical problem which already has been asked in GATE previous year paper related to this topic only. So are you ready to go to learn that problem? I am sure you are ready, right? So let's go for it. Alright, what do you think? Nothing is changing, don't worry, I'm just going to change it. Okay, here is it. So here is the question in front of you right now. You can read the question and you can solve the question. Can you solve it itself? Okay, try my dear. Just pause this video and try if you can. Otherwise, don't worry. Just keep watching. I will make you understand each and everything what you need to understand in this topic, right? So what we got here, in sand casting of hollow part of lead, a cylindrical core. So first of all, we need to know everything. Every formula about cylinder. Just like here, most useful thing is volume, because they have said that volume of the core is required to find out what? To find out force, upward balancing force. So here is the net force we have to find out in Newton. So we got the formula F is equal to Vg, density of molten metal minus density of core. Okay, so V we don't know, we have to find out. G 9.81, rho M 13, 1130 minus 1600. So V into, we can solve this till now, just we need to find out volume, then we can get the answer of it, right? So what we require right now for solving this, can you guess? Yo, yeah, you are right, calculator. So 11,300 minus 1600 is equal to 9700 multiple 9.81. Yeah, so what we got here, 95157. Let me repeat it again. 11300 1600 is equal to this much, 9.81. And remember, this all is in SI, because we have given kg per meter cube, kg per meter cube. Also we have to find out in SI, because we have to find out force in Newton. Remember that. Now I will go for the question, whole question, then I will try to solve it. So in sand casting of hollow part of lead, a cylindrical core of diameter. So its diameter is how much? 120 mm, and height is 180 mm. So its height is 180. Now you can see the question. If anyhow we can able to get the value of volume, we will get the answer, right? Volume must be in SI, that means in meter cube, right? And now the biggest problem is here right now. Not it's the biggest problem, but probably it can create a biggest problem for you if you don't know the conversion from unit conversion, right? So I know what is milli. Everybody I know. Everybody you know also what is the millimeter, right? So what we got till now, we got here that a cylindrical core whose height is 180 mm and whose diameter is 120 mm. So most important, what we have to find out, that is we have to find out volume of the cylinder. Now most important, what we need to, how we can find out, we need to know the formula. We need to know the formula for finding out volume of this cylinder. So the volume of the cylinder formula is pi by 4 d square into h. Okay, so pi by 4 d square is what? 120 square. H is 180. Again I am going to ask you a simple question. What we required right now? Can you guess? You are right, we required calculator to solve this. So 120 whole square into 180 is equal to this much, into pi divided by 4 is equal to how much? Okay, let me write 336. So we can say 2.0357 into 10 to the power 6 millimeter cube, right? 10 to the power 6 millimeter cube. Got it? Now we have to convert this into meter cube. Now as you know, 1 meter is equal to how much? 1000 millimeter. Then 1 millimeter is equal to 10 to the power minus 3 meter. Now what we have to write here, I am sharing you each and everything, right? Okay, so 2.0357 into 10 to the power 6 into 10 to the power minus 3 meter cube. I'm just putting the value, this value here. That's why I have shared. Are you getting my point? Yeah, I hope you are getting me. That's why you were watching. Otherwise, you could go somewhere else. You could watch some any other video, maybe song and all that. Okay, no problem. That's your problem. Let's solve the question, right? So probably you will be in. Okay, no problem. Solve the question. So what we got? 2.0357 into 10 to the power 6 into 10 to the power minus 9 meter cube, right? Now what we can do, we just need to add here. So 2.0357 into 10 to the power minus 3 meter cube. So what is this? This is in meter cube. That means this is volume. So what is, whose volume is this? Core. This is the volume of cylindrical core, right? I hope you understand it. Now what we have to do, what we are going to do, what we are exactly going to do with this volume, we have to put value, this value here, right? So let's put this value 2.0357 into 10 to the power minus 3 into 95157. If I did not do any mistake in the calculation, then probably I'm going to get the right answer. So what I'm getting here, this is in Newton, because we did all in SI. We have changed all in it into SI. That's therefore the answer is what we got here, 193.7111 Newton. So can you match the answer with which option we can see the answer right now? It's A. So A is the right answer for this topic. Now let's overview this topic again. That's why it will be in your mind for little long time. If you'll do revision, watch my video or write down all these things on your paper, that would be much better, because paper work is also important. So here is the video, here is the formula again. So what is the formula for upward balancing force? That is V, that is volume of core, not velocity, it's volume of core. Remember that G, acceleration due to gravity, and rho m minus rho c, that is density of molten metal minus molten liquid metal, you can say that, minus density of the core material. So this is all about upward balancing force, and how I have shared with you, how you can solve numerical problem, I have also shared with you. So thanks for watching. See you soon in my next video. Bye bye.